Before we can get to all the fun calculus stuff, let's do a quick review on functions. These are very important, especially for this chapter, but for later chapters as well, okay? So a quick review, what is a function? A function usually has a lowercase f like this. It could be g, it could be h, but this is pronounced f of x or f at x, okay? It takes in a set of input values x and produces a set of output values f at x, or some people call them y. So it takes in numbers, spits out numbers. So for example, this function f at x equals 3x squared plus the square root of 4x plus 9. And we want to evaluate the following. So let's start with the first one. This guy's pronounced f of 0 or f at 0, meaning we are going to take any x that we see and replace it with a 0. So on the right hand side, we get 3x squared. Instead of x, I now have a 0. Plus the square root of 4 times x, which is now 0, plus 9. And then, of course, we want to simplify this as much as we can. 0 squared is 0. Anything times 0 is a 0. Plus the square root of 0 plus 9, so that's the square root of 9. And this guy simplifies to the number 3. So if we input the value 0 into this function, we output the value 3. Okay? Now, what about negative numbers? Same thing, it's just still a number, right? So on the right-hand side, we get 3x, which is now negative 1, squared, plus the square root of 4 times x, which is now negative 1, plus 9. All right, let's crunch this up. Negative 1 squared is positive 1, 3 times positive 1 is 3, plus the square root, this is negative 4 plus 9, which is 5. And we leave it like this, 3 plus square root of 5, this is the exact value. So later on when you have practice questions or quizzes and you're asked to input a value, if it says exact value, don't crunch it in your calculator and round it. Leave it as 3 plus square root of 5, okay? Now let's get to the real fun stuff. I call it fun, I don't know about you, but it's called calculus without numbers, or math without numbers, okay? So here I have f at a, or f of a. Well, where's the number? All I'm doing is I'm replacing my x with the number a. So anytime I see an x, I'm going to replace it with a. So on the right-hand side, we get 3x squared is now a squared, plus the square root of 4x, so that's the square root of 4 times a, plus 9. Okay, and again, we want to simplify as much as we can, but we don't know these cool properties like 0 squared is 0, negative 1 squared is 1, because this is just a. So we're just going to leave it as 3a squared plus the square root of 4a plus 9. And that's it. This is the simplified exact value. Now let's move on to the next one, which is a little bit trickier. This time we have a number, 2, but we also have this weird plus h thing. We're going to see this over and over and over again later on in this chapter. Okay, so f of 2 plus h. No worries, we're just going to replace every x we see with the 2 plus h. So, scrolling up a little bit, we have 3x squared. So now we're going to have 3 instead of x, it's 2 plus h squared, plus the square root of 4x, so it's 4 times 2 plus h, plus 9. And again, we want to simplify as much as possible. Now, quick tip for you guys, because I see this as a common mistake in a lot of tests and exams that I've marked in the past. When we have 2 plus h squared like this, remember, this is essentially saying 2 plus h times 2 plus h. It is not saying I'm going to square the 2 and square the h, be done with it. Don't do that. I see a lot of students make that mistake. Whenever you have a square, it's that thing times itself twice. There is a shortcut formula for this. You're going to square the first number, square the last number, and add 2 times the 2 numbers multiplied. That is a shortcut for expanding this. If you don't like that, stick with FOIL, stick with whatever you normally use for expanding brackets, okay? So expanding this guy, I get a 3 times, I'm going to use my shortcut for the perfect square. So it becomes a 4 plus 4h plus h squared. Again, if you don't like the shortcut, you're like, my brain has too much to memorize already from all my subjects, just expand this out. 2 times 2, 2 times h times 2, h times h, and then you just have to simplify a little bit. Okay, underneath the square root, we have an 8 plus 4h plus 9. Number crunch. Let's keep going. Multiplying this first bracket through, 3 times 4, 3 times 4h, 3 times h squared. We get 12 plus 12h plus 3h squared, plus underneath the square root, I can combine like terms. The 8 and the 9 gives me 17 plus 4h. And that's it. There's nothing else I can do here. This is the final answer. Okay, our last one, part E, 0 numbers again. F of a plus h. So we need to replace every x that we see with an a plus h. So let's go ahead and do that. On the right side, it's 3x squared. So that's 3a plus h squared. Plus the square root of 4x, which is a plus h, plus 9. So it's kind of like a puzzle piece. Whatever piece has an x on it, you're just going to replace with whatever's in the bracket. And now, of course, we want to simplify as much as we can. So let's expand this bracket, a plus h squared. Again, I'm going to use my shortcut. It says square each of the terms, then add 2 times each term multiplied together. Okay? Plus the square root of 4a plus 4h plus 9. So you're just expanding everything, meaning multiplying everything through the brackets. And then 3a squared, because you're multiplying this 3 and the a squared. 3 times 2ah, well, 3 times 2 is 6, so that's 6ah. And then 3 times h squared is 3h squared. Underneath the square root, there's nothing really we can do. We have 4a plus 4h plus 9. Don't try to smush them together, because that's like asking you to add 4 cats, 4 dogs, and 9 humans and trying to give you one number. Can't do that, right? They're separate entities. Keep them separate. Okay, whenever we're talking about functions, we have to review this concept called domain and range. Remember, a function takes in a set of numbers and then spits out a set of numbers, right? So what is this set of numbers that's allowed to go into my function? That is called the domain. And whatever is allowed to come out, whatever is allowed to be outputted, that is called the range. So you might be asking, Jess, can I just put in any number and then just see what comes out? Yes, but sometimes things aren't allowed. For example, if I have 1 over x, that's my function, let's say. Am I allowed to put in x equals 0? Well, x equals 0 is 1 over 0, which we know breaks our calculator if you punch in 1 divided by 0. That is undefined. So in this example, 0 will not be in the domain, okay? So let's take a look at some examples here. We want to find the domain and range of each function. This first one, y equals 2x plus 1, we've beat this to death from grade 9 to grade 11. This is y equals mx plus b, which is a straight line. So if you think about your straight line, it has a y-intercept like this and a slope. We have a line that looks somewhat like this. Give or take, it's not really drawn to scale. But this line extends forever and ever and ever, and it keeps going, right? So it's going to hit every single x value. For any x value, I can put in and do 2 times that x plus 1, and I get a valid number, right? Whatever x value, I do that, I'll get a valid number. So the domain is actually everything. So x belongs to the real. That's what this is read at. X belongs to the reals, meaning x can be any real number. Any number you can think of, you can put it in for x. How about the range? Well, this extends forever and ever and ever, so eventually it's going to hit every single possible y value out there, right? All the positives, all the negatives. So the range is y belongs to the real. Now let's move on to the next one, part B. This is a quadratic. We beat this one to death in grade 10. So it looks like a U. It's a U that opens right side up. It's going to have the vertex 2, 3 like this. Give or take, this is how the graph looks like. It goes up and up and up forever and ever and ever. Now, this function keeps going, right? So eventually it's going to hit any x value, meaning I can put in any x, positive, negative, 0, doesn't matter. Subtract 2, then square it, which I'm allowed to do with any number, and then add 3. So the domain is going to be x belongs to the real, because I can put in any number in for x. Now, there is going to be a restriction on my range. If you notice, my values, if I put in x, it could be any number, but once I subtract 2 and then I square it, this part here is always going to be positive. Because when I square a number, no matter if it's positive, negative, I square it, I'm still going to get something that's positive. So the smallest this part could be is 0, right? If I put in x equals 2, I get a 0. So this part right here has to be greater or equal to 0. So if I'm adding 3 to something that is at least 0, I'm going to get something that's at least 3. You can see that from the graph as well. This graph goes up and up and up forever and ever, but I can never reach a negative y value. I can never reach a y value of 1. my y value is going to start at 3, okay? So the range here is that y belongs to the real, but y has to be greater or equal to 3. Okay, let's take a look at this next one. This one is x squared plus y squared equals 4. Some teachers don't really mention this in calculus, but I find that there's some application questions that may require this, so it's worth mentioning. This is the equation of a circle. So more specifically, any equation of the form x squared plus y squared equals r squared. This is the equation of a circle centered at 0, 0 with a radius of r. So since this can be written as x squared plus y squared equals 2 squared, which is 4, I know the radius is 2. So trying to draw this in, now I know I'm not a perfect drawer, just bear with me. I know that it's going to intersect my axes at the points 2, 2, -2, and -2. So trying to draw this in, pretend with me for a second that that is a perfect circle. Okay, so pretend that's a circle right there. I might do some editing, make it look perfect. Okay, so that is a circle, so let's find the domain and the range. What are the restrictions? Well, you might be thinking, why are there restrictions, Jess? I can put in any number for x and I can square it, no problem, right? But the problem is if I put in a number for x and square it, and I add any y squared, which is always positive or 0, I'm going to get numbers that may be bigger than 4. For example, if I put x equals 3, 3 squared plus any y squared is going to be bigger than 4, which is not allowed because my equation says that x squared plus y squared has to equal 4. That's a rule. So the domain here is that my x could be as small as -2, my x is as big as +2. So x here is still a real number, but x can only be between -2 and 2. It can't be anything bigger because then we won't get the right side equals 4. For my range, I could have the same restriction here, right? Y is any real number, and my y has to be between -2 and 2, and depending on what number that is, I need to find an x value that makes this equation true and equals 4.